So yeah, as I said, we're now into the panel discussion, and this is going to be chaired by Jim Cownie. So we'll introduce him. But before we do that, we're just going to load up our first poll. Hopefully, this will give some of the panelists some things to talk about. There we are. Tim's put that up for you. If you could all answer that poll with some questions, that'd be brilliant to see what happens. And I'll hand over to Jim now. Welcome, Jim.
Hi, hope everyone can see me. No one's sent any questions yet, and I hope all our attendees, speakers are still here, because otherwise we're going to be done very quickly. I have some history in OpenMP. I'll just say who I am. I have some history in OpenMP. I was at Intel for 10 years, or maybe longer than 10 years, and I worked on the OpenMP runtime there, which became the LLVM runtime. So I was actually responsible, the code owner for the runtime in LLVM, which I guess is being used by a lot of people now, which is good. So I have sort of a runtime bias, but know quite a lot about OpenMP, and you can blame me for a few things that got into the standard, like the speculative locks, which we managed to suggest should go in, because that's a hardware feature that's available in multiple processors, in particular those from IBM and Intel and soon ARM, and wasn't accessible from OpenMP. We found a way to make that relatively easy to use from OpenMP. And also I pulled out the distinction between monotonic and non-monotonic dynamic schedules, and we had some interesting discussions in the standards body about those before finally deciding that, at least from OpenMP 5.1, maybe even from 5.0, that dynamic schedules are non-monotonic by default. So I see there's at least one question come in. What's that? So the question from Mark, I guess for everyone, is would you write a new C++ program that aims at performance portability with OpenMP, or would you rather have SYCL? Who on the panel would like to take that one? Jeff, so you can say something on that?
I can probably say something about it. So, you know, being biased towards OpenMP, certainly the answer is OpenMP. The more technical answer is there is actually, to my knowledge or in my belief, there shouldn't be a performance difference or a difference in the way that the SYCL compiler and the OpenMP compiler would handle the code, as long as the code is very similar. And so you should see the same performance in SYCL and OpenMP. The benefits that you will get from OpenMP is less code to handle buffers and you know, glue code or boilerplate code that you need to construct SYCLs, buffer objects, and get that things fed into the kernel. So OpenMP will save you a little bit of writing and should give you the same performance as SYCL. At least that's my perspective.
So I'm going to answer a little differently, if that's all right. That I would choose to write using the standard C++ parallel algorithms as the starting point. I think, in my opinion, SYCL is a little late to the game in that C++ has largely adopted the the parallelism features that are needed. And there's some gaps there, and they're being developed into you know, what is it, 24 I think is the next one. But as a whole, I think C++ is beginning to provide the things that are needed.
Aren't some of the data movement issues still an issue with C++?
Sure. There's your data movement's one thing that's not yet addressed, and for that, you know, I think I presented NVIDIA's vision, which is that we would use the directives as a stopgap for that while that's being solved in the base languages. And I would also point to, you know, all of the major hardware hardware architectures out there do have support for a unified memory now that gets you pretty far along the path.
I wonder if the Jamil and people like that who are actually writing code could kick in here. We're all on the implementing side, and so we're not really the right people to answer this question. So, Jamil,
well,
you have something?
Yeah, this is Chris Mayer from the Met Office. So,
yeah,
one of the reasons we're generating our own parallel code is because not only is the hardware changing very rapidly, the programming models are evolving very rapidly, and they're changing and evolving faster than we're developing a science model. And so what we decide to do today may turn out, when we started writing the new model for the Met Office, say in 2013, maybe 2014, SYCL didn't exist. But with using this approach, we can sort of have a SYCL implementation if we wanted one. I mean, it would be some work, and we certainly can't do that yet. But we could choose to have a SYCL implementation without having to choose our science code, change our science code in principle. And it's the same with OpenMP. OpenMP is changing and evolving to take account of new changes in hardware, and some of those constructs, when we started, didn't exist. Because the hardware was very, very new and there wasn't any programming model for doing it. So we're kind of building our own abstraction where we don't see SYCL and we don't see OpenMP. We capture the parallelism that we need to do and then generate that code so that we can choose whatever we think is most appropriate at the time. So the approach we've taken is not to choose a specific programming model deliberately. So we're abstracting that away and doing that later.
Does it worry you, Chris, that by moving to your domain-specific language, which is non-standard and pretty much belongs to you, that you're restricting the number of people, and that there's who can work on the code and whom you can bring in and rapidly have, or do you think that it's your scientists doing it and it's also obvious to a domain scientist that that's not an issue?
Yeah, I mean, that's a good question. So hopefully the API we've constructed in conjunction with our domain scientists means that what they're doing is obvious, but we do need technical HPC programmers and experts to develop the parallel code and the code generation for that, and that's kind of not what our domain scientists are doing. So one of the issues of having this is, you're going to have to, the framework that we're building is going to have to be around for a while, and we have to support it. So that is an overhead for us. Having said that, compared to having to debug lots of code, parallel code written with bugs in from our domain scientists, or even from ourselves, is also a big overhead. So doing it this way, we get a different overhead, if that makes sense.
Makes sense. Anyone else got things to say on this? Jamil, are you still here? Maybe he's not, or maybe he's muted. Anyone else got questions? Come on, what else do you want to find out about people? Got all these people here, and anyone on the panel? What would you ask the other people on the panel? Okay, well, I'll ask someone. And a lot of the discussion of compilers didn't explicitly mention LLVM, and the comparisons of performance that Phil was making, for instance, didn't include LLVM. Is that because actually the ARM compiler is LLVM++, and therefore it's implicitly there? Or is it that LLVM is not viewed as being competitive with GCC, which would surprise me, I have to say?
That's a good question, Jim. Yeah, so on that, I didn't mention, the two different tool chains just offhand, really. But it's certainly not the case. I mean, in terms of GCC development, we do at ARM, we do a lot of development for that because, there are areas outside of HPC which obviously use the GCC toolchain quite heavily. But we also support the LLVM chain as well. And there's certainly no reason why we're not doing both. We're actively developing for LLVM. And in terms of performance, so GCC 11 has recently introduced some code in the runtime to handle, I think it's locks better on our architectures. And in LLVM, there's been something like that for a while now. So GCC, I guess, is catching up in terms of the runtime. And that's about it, really. I think, as we see more cores certainly on ARM architectures, like other architectures, we'll be seeing more cores over the next few years. These OpenMP runtimes, both, from LLVM, GCC, they'll need to keep up with that in terms of how they can handle, memory accesses, shared memory type data transfers, and, locks and that kind of thing.
Something I've noticed over the past several years is just the incredible velocity that the LLVM toolchain has made with regards to OpenMP, and I think that comes down to it's got a friendly license that has enabled vendors like Intel, like NVIDIA, like AMD, like IBM, like ARM to jump in and work together and collaborate. And so I think the OpenMP collaboration has expanded out to include LLVM in some ways because of its friendly license. And it also has meant there's been times where features have been able to be prototyped in ways they couldn't have previously, because now there is a relatively mature compiler that people can touch and can work in. And so I think, I don't work in the compiler portion, I work in the applications portion, but just seeing the velocity that LLVM has taken in the last several years has been impressive. And I'm personally getting asked a lot more often by people about using Clang in their code or using Flang as it's maturing. And that question wasn't asked to me 3 years ago.
Yeah, Flang is slightly a concern, of course, but I quite agree that the license has been critical there, and has led to exactly the thing you're talking about, that it's a good environment for people to do research, as we saw earlier.
Yes. No,
people
sorry.
are doing research in that environment, and also the contributions from Argonne should not be discounted there. They've been doing a lot of work in improving OpenMP optimizations within LLVM.
Yes, I would like to add just what Jeff said is more or less what happened to us also in the University of Basel, that our first work was using GCC, but we migrated to LLVM also, not only because of the license things, but also because the code was slightly more accessible, or how can I say, maybe easier to follow. And the only problem we had is that some of I don't really know how it is right now, but at the time we started developing the techniques and some features, we had to compile the LLVM runtime with the Intel compiler, since Clang didn't have some of the functions, or I don't remember exactly what it was, but Clang had some problems. Yeah.
So there's one related question also in the Q&A box. So there's actually a meeting between all the major compiler vendors in the OpenMP ARB to collaborate on the different OpenMP features that have to be implemented, who does what, how they are implemented. So there's a tight cross-vendor collaboration to bring Clang as the main Clang up to speed with OpenMP support, but also then to downstream those changes back in the individual commercial compilers that are then produced as part of the vendor-specific offerings.
There's also for instance, I can only speak for LLVM, but there's a intercompany meeting that happens once a week or once a fortnight of Clang OpenMP developers who are divvying out some of the work between them. You know, particularly we're going to do a load of work on something for GPUs. Okay, well we'll do something in slightly different area, and making sure that it does indeed all get up. I mean, obviously all of these things have to meet the license requirements. They have to have tests. They have to be properly documented and all of this. So you want quality code in there, and that's entirely reasonable. But there is certainly cooperation within the LLVM environment in that, and that's an open meeting. So if people want to join it, they should find out about it. And there are mail lists and so on, and you can just join. Should we move on a little? What else have we got here? Mark Bull wants us to work out how do we get that the specs are impenetrable. Well, maybe that is slightly reasonable. We do tend to talk about things like contention groups, which came up in some of the discussion earlier. Jeff mentioned contention groups, and if you haven't heard that term before, it's not utterly obvious what it means. I think most would agree. So Mark is saying, how do we get the word out about all the new things? Anyone have any views on that? I mean, we're trying to do it. That's what we're here doing. But I'm not sure how we go further. Anyone have any opinions?
There's a little bit of a chicken and egg problem there, right? I mean, we get the word out that here are some great new features, but then if the compilers aren't ready for people to try it, then it's hard for them to get excited. And on the flip side, it's hard to get a compiler writer excited about a feature if there's nobody ready to use it. So it's been a pretty significant challenge. I think Loop is one example that I've been connected with. It's here we are 2 years beyond when 5.0 came out, and we're just now starting to see usable implementations of Loop. You have things like the meta directive that are huge and enormous and hard to understand. I think OpenMP puts out the examples document, and I think there's a lot of hard work goes into that, but I think what Mark's saying here is perhaps we need to do better and make more complete examples, perhaps. And I think that's maybe a challenge to us on the committee to take that to heart and come up with more complete examples. There has been a push from some members to not accept a feature until an example exists, and maybe that's one possible solution. But he's right; it's a challenge. It's complex.
So apart from the examples document that Jeff was mentioning, we obviously have OpenMP tutorials that are being recorded and at least try to explain several of the most important features of OpenMP. These are all on the YouTube channel of the OpenMP ERP, so they should be easy to find. Then there are at least books that are covering OpenMP up to OpenMP 4.5, I believe. So one of the incentives is if you buy those books, the authors have more incentives to write the OpenMP 5.1 book to explain the specification. But yes, we need to do better on that. And so if you have suggestions how we can improve the spreading the word, I'll be happy to hear that and happy to support that.
Yes, it is slightly frightening that even at SC this year, one of the posters was a poster. I won't say too much because it would be a bit mean, but it managed to compare features of OpenMP with other programming models and used OpenMP 2.0 as its OpenMP reference. And it's slightly concerning that that got through the reviewers and everyone and got it into the poster. It suggests that we're slightly not publicizing things widely enough, maybe in academia and in education, if people are unaware that OpenMP has changed in the last 20 years. I don't know how we overcome that, but it is slightly worrying. Shall we move on to something else? There are some questions here. Konstantinos, do you want to be unmuted so you can ask your questions, or shall we read them out? Okay, let's go for those. So Konstantinos is asking, for GPU offload, the choice of compiler has a big effect on which parallel constructs you need to use, especially when it comes to the SIMD directive. So you end up with multiple versions of the code, depending on the platform and the compiler, either with ifdefs or using the other features that you can use within OpenMP to achieve that. And that's messy and unpleasant, and very reasonably doesn't want to do it. Is it unavoidable, or is there magic? Do the directives that Jeff was suggesting, are they sufficient? Do we have opinions, people?
Well, my opinion is always going to be the same one, and this is precisely why we're trying to control what parallelism we produce, because we want to be able to have single science source code, and there's lots of new things in OpenMP in the newer versions of the standards that go a lot further beyond OpenMP 2. OpenMP 2 is relatively simple to use and quite effective, and beyond that there's a whole load of different things you could do, and what you can do, what you should do, depends on the architecture, depends on the compiler, and depends on what the problem you're trying to solve. And the problem is that some of those things are not, the problem you're trying to solve might stay the same, but the architecture, the implementation it might well change. And then does that mean you can still have the single science source? And from our point of view as an application, it looks like that we can't. So that's why we're going to end up having to control that and generate our code. And then we can make use of the appropriate features that are in the newer standards of OpenMP.
Yeah, I mean, we've seen it at various workshops like this where people will come with code and they'll run it through 3 different compilers on the same platform and get wildly different results, because platforms have gotten a lot more complex. When OpenMP was designed initially, a single flat level of parallelism was a reasonable assumption that worked really well, because that was what was available in the market. And now the market has changed dramatically, and OpenMP has changed along with it. And it's how do you write code that runs from on a CPU and a GPU and a DSP and expect it to? Is it realistic to expect a single directive to work across all of them? In some ways, perhaps not. You can minimize.
Jeff, a minute ago, you were telling us that the answer was just to write standard C++ with the algorithms and so on, and now you're telling us that the added complexity of OpenMP is still not sufficient. It seems slightly inconsistent.
I don't think it is. Because what I was moving towards before you jumped in there is that for a lot of data parallel code, if you can expose the parallelism, you can make a first attempt using something like loop, something like parallel algorithms to get good enough performance to start, and then you start to specialize. And so the meta directive is an example. I'm personally not a huge fan of the meta directive because of the complexity of it. And when I look at a presentation, I spoke to someone at a conference, and they had one column for OpenMP. For GPUs and CPUs, they had 2 different directives, and they said, well, the meta directive. Well, the meta directive still involves writing 2 different directives. It's just resolved by the compiler. You know, I have long been a believer of something like loop and something like the parallel algorithms, where you expose where there is parallelism and you have a fairly advanced compiler and runtime to make a best effort of getting you good enough performance. And when good enough isn't good enough, well, then you're going to have to specialize, and that does mean writing non-portable directives for the places where it really counts. You can get a lot of your code running with fairly generic parallel, teams distribute parallel 4 collapse, and then the really performance critical parts, you may have to write more specialized code. And OpenMP is an abstraction that enables you to do that.
Okay, so that does make reasonable sense. And I guess so this is actually a question that came up in, I think it's slightly more or less relevant here, and since you're talking, it came up yesterday in Tom's tutorial, where we were generating code and offloading it to GPUs, and someone was saying, well, how am I going to use the matrix engines that everyone's putting in from OpenMP? And my hope and expectation is that those will end up looking like BLAS functions in CUDA or whatever at some level, and I'll just be able to call them from the OpenMP code that I already am using and offloading. But maybe you can tell us whether that's a reasonable expectation.
I have 2 answers. One is libraries. There are things like BLAS that, while not standard, they are fairly standard. They're standard enough that everybody supports them. And you know what? C++ is adopting a math language interface that's BLAS-like. I think it's coming in, I don't think it's in 20, I think it's in 23 or 4, whatever that is. And Fortran has matmul. Our compiler chain will recognize a matmul and pass it all the way down to our tensor cores for you, including potentially changing the data type if it's appropriate. So, I think, is it up to OpenMP to define those things? Well, I think the languages and the libraries are already doing that pretty well.
Great. So libraries is the answer, basically.
Libraries.
At some level. Good. I'm glad that's a good answer from my point of view. Konstantinos has another one here that we'll just do quickly, I think, because he's asking specifically about latest new feature supporting compilers, PGI plans for OpenMP support for offload. Do you want to say anything about that, Jeff, or should we move on to something else?
Well, no. So he points out that at SC19 there was a huge discussion at the BOF about the fact that the NVIDIA compiler chain was being upfront, saying there are things that our initial implementation will not support on the GPU because either it's not scalable enough, or it's not something that we believe needs the engineering effort for our first implementation. Does that mean it's never going to be there? No. And are we unique in that? No. Intel at the exact same event at supercomputing at the OpenMP booth presented that they were also implementing a subset for the GPUs for their initial implementation. And so, right now, as far as I'm aware, there are no complete OpenMP 4.5 compilers. There are no complete 5.0 compilers. There are no 5.1 compilers. We as vendors need to hear from the users, here's how to prioritize the features, because it takes engineering effort. Not all features make perfect sense on our GPUs, so we're going to prioritize them lower than the ones that we view as things we want our developers using and to get the best use out of our GPUs. And I think all of the vendors share that. Do we need a gentleman's agreement on what that subset is? Some people think we do. Some people would say, isn't that what the specification's for in the first place? I don't know the answer to that, but.
Jim, can I make 2 comments on that? So the first one is actually about the last sentence that Jeff just said. So I'm mildly worried that the subset that Intel IBM, ARM, whoever implements for accelerators is slightly different enough so that, in reality, you get non-portable code. So, that's where the ARB also strives to, bring the vendors together and make them talk to each other so that the subset is as compatible as possible. And the other thing is, coming back to the original question, this is not so much an OpenMP issue. This also relates to the base language, right? So there's only so much of an Fortran subset that makes sense to be offloaded to some device like a GPU. So you wouldn't expect that you could do like full HDF5 file export from a GPU. So there are already kind of restrictions coming in from the base language in terms of what makes sense on a GPU. And so OpenMP is no different in that regard, that there's also only a sensible subset that makes sense for a particular target platform like a GPU, like an FPGA or a TSP.
Okay, thank you. We have one more question, then there's another little survey, and then Tom wants to wind up. So the other question from someone who wants to remain anonymous, so they're trying to wind us up, is what's our opinion of Fortran co-arrays versus using OpenMP? And I would say that they're actually slightly different, because co-arrays are a distributed memory model and OpenMP is not. However, I'll let everyone else throw in their 2 cents.
So let me give you a short answer. So this is the same question as when will OpenMP replace MPI? So as Jim rightfully pointed out, Fortran co-arrays are a distributed model, like partitioned global address space kind of thing, whereas OpenMP is an in-node shared memory and heterogeneous programming model. So it has a different mode of operation. And so I do see, if you really in co-arrays, I would see them both implementing different concerns. So you can have co-arrays on the outer level of your parallelism going across your cluster, and then use OpenMP within your individual co-array image to do multi-threading on the data that is hosted on that particular node. So they kind of, in my mind, complement each other, like MPI and OpenMP complement each other as well.
Anyone else want to say anything on that, or shall we wind up?
I mean, I think they're complementary as well. I think it's I've had discussions with people before. Is co-arrays a competitor for MPI? Is it a competitor for OpenMP? Is it? No. It's a choice you can make. It is an option, and I think what we as OpenMP implementers and specification writers, what we need to do is ensure that it's well defined what our interaction is with them, and then it's up to the user of what meets their needs better. If one thing needs better than the other, then great, use that.
Yeah, I'd just like to add pretty much the same. If we as compiler vendors hear enough feedback from the community, then co-arrays is one feature that may be added to the compilers. But at the moment, as you probably know, it's not supported in every compiler. With co-arrays, we've got the addition as well, because it's internode, possibly tuning for particular interconnects may come into the development as well. So it gets more complicated than just looking at OpenMP optimizations and run times. But it would be great to hear back from the community if there is a particular need for co-arrays.
Okay, I think we're out of time, because there's one more question for you to answer, and Tom also wants to wind up the whole session. So I'll just say thank you to the panelists for contributing, and thank you to the audience for your questions. Tom, over to you.
Thanks, Jim. Thanks for a really lively and interesting panel discussion. It's nice to be able to have panel discussions at these events, so it's good that we're able to bring that to this to Zoom, the Zoom platform as well. I'll just leave the poll up just for a few more moments, just for people to finish answering. It's nice to see what the community is basing themselves around. I thought it was very interesting, the first poll about the tasks. Most people aren't really exploring tasks yet, but as Jeff pointed out in his talk and the questions, maybe tasking is going to be a critical part of getting the most out of these heterogeneous nodes that we're seeing. So I'll end this poll. It's interesting. It seems most people are writing OpenMP 4.5 codes at the moment, which is really good to see. It seems like most people are keeping up with where the current compilers are and are chomping at the bit to get the latest compilers, the latest support for OpenMP into their compiler suite. So hopefully that means that we'll see 5.0 and 5.1 support very soon. Let me turn this back on. There we go. So thanks to everybody for coming today, and thanks to all our speakers. There's lots of people that I need to thank. So first of all, to Tim Lewis, the conference organizer today. He's been fantastic at getting everything going and looks after us as a community fantastically. Then there's the conference chair, Simon McIntosh-Smith, and the program co-chairs, Mark Bull and James Cownie, who was leading that panel session just now. Thanks, of course, to you all. Also, I'd like to thank the Science and Technology Facilities Council for including this event today, the OpenMP user group, as part of their Computing Insights 2020 extended program, and in particular to Damien Jones for promoting this event within the HPC community. Obviously, as support from all the sponsors, which I've put at the bottom of this slide, we're very thankful for that, and obviously all the speakers today. So Chris, Jonas, Jamil, Phil, Jeff, Michael, and of course Jim for leading the panel session. Thanks for your time and for your really interesting talks. And obviously thanks to everybody for joining us today. Hopefully you found it really interesting. I've had a brilliant afternoon, and it's been great to hear all the talks. Keep in touch, use Twitter and use the website for taking part in this community. Most of the links are also available on the OpenMP website, and there's links to forums and other ways to interact with the OpenMP community there. Just a couple of housekeeping things before we finish. Recordings are going to be made available to all the attendees soon. Look out for those next week. For those of you that attended the tutorial yesterday or couldn't, all the materials are available online. We covered a lot of OpenMP 4.5 and some of 5 yesterday, so if you're interested in looking at that, that's available there. And watch out in your emails as well for a feedback survey. It'd be really lovely to hear what you all thought. So thanks everybody for coming. I'll close the afternoon there. We'll leave the Zoom running for just a few more moments. But thanks everybody for joining, and hopefully we'll see you all at the next event, which is going to be in Bristol around September time in 2021. Thanks everybody.